Okay, so I may have said in the last video that we were going to go to quadratics next. I didn't pay attention to my schedule. Psych, we're going to best fit lines. We're going to do a little bit more with linear first. So now we're going to deal with linear versus nonlinear relationships. A and B are obviously fairly linear. Stats-wise, those are very linear. Precalc-wise, those are mostly linear relationships. C, D, and E. C is no relation. D and E look like they have curved relations. And so that's what all five of those are. But so what we're looking at is linear relations. So in a graph, it's pretty easy to tell visually. Do they kind of resemble like a trend, a line? They're never going to be all right in a line, right? We're never going to see them line up perfectly unless we've made up the data for some reason. Much more often, you will see something like this. It's a clump around a linear area. So we're going to deal a lot with scatter diagrams in this section. When we are given a set of data, we're going to need to be able to create a scatter diagram, or a scatter plot is what I tend to call it, from that data. And then we're going to want to be able to fit a line and use it for predictions. To graph it, we're going to treat the independent variable column as the x-coordinate, the dependent variable as the y-coordinate, and then make each row its own point. You may have done this before, you may not have, but that's what we're going to be working with. Figuring out what's independent and what's dependent is a little bit harder. A lot of times they'll tell you, the problem will say using this as x, or let this depend on that, right? This depending on that means this is the dependent variable and that is the independent variable. So that would be your x. Y depends on x. So that's the idea here. We're going to draw a scatter diagram of this set of data. This is a completely made up set, so you never know what it's going to look like, but we will do this one out. We have, it looks like I have 10 things on, 10 hash marks on each side, so we're going to try to label these nicely. My y's need to go from, looks like 100 up to 140. 105, 110, 115. 20, 125, 130, 135, 140. That works nicely. And this needs to go from -10 to -20. So let's see, -10, 12, 14, 16, 18, 20, that'll work. 14, 16, 18. All right, so now we're just going to treat each one of these as a point. So at -20, we're at 100. And at -17, we're at 120. -15, we're at 118. Should be about here. -14, we're at 130. And -10, we're at 140. Okay, so there's our scatter diagram. Note a couple of things. First of all, you always have to make sure that your scales are even. They don't have to be equal, but they have to be even, so that each hash mark, each distance, is the same amount on the scale, right? So if it's this much is 4, then you need to make sure that this much is 4 even up higher, right? No matter where we are, if it's on the y, if this is 4 to start with, it's 4 everywhere, right? Same thing with on the x. If it's 2 everywhere, you want to make sure it's 2 everywhere. So you want to scale that first before you do your points. If you make each hash mark one of your x's, it won't look the same. It won't look correct, because we need to make sure that each scale is a proper number line, essentially. So make sure that you're paying attention to that. And note that I don't have to start at 0, 0. That wouldn't have helped me here. That would have made it awful, right? So we can start, and if you need to, you can draw the little squiggle in the axis to help you feel like, okay, I'm close. But as long as you label it, that's what matters. Okay. Now, normally in class, I'd assign you 2 points. You'd find the equation of the line in slope-intercept form between those 2 points. So I'm going to ask you to pick 2 points. 1 and 2, 1 and 3, 1 and 4, 1 and 5, 2 and 3, 2 and 4, 2 and 5, 3 and 4, 3 and 5, or 4 and 5. Pick 2 points and find the equation of the line between those 2 points. Remember, you can pause it here if you need a little bit more time. Okay, I've done this in class before, so this is the data that I was given when I've done it in class before. Between points 1 and 2, we have a 3 over 20 x plus 122 line. And so we have all of the different combinations here: 1 and 2, 2 and 3, 3 and 4, 4 and 5, 1 and 3, 2 and 5. Oh, that was all I had. Okay, so we don't need this part. Sorry about that. So I didn't do all of them. Hopefully the ones you picked are on here. If not, send it to me. Maybe I can update that for us. But all of these lines have some interesting trends, right? Now, are any of them the best line? Maybe. If we look at this here, the line between negative 2100 and negative 10140 is probably the closest one to being the true trend. So between points 1 and 5. Of course, we didn't do that one. But it's not going to be perfect necessarily. Using a calculator, though, we can get the perfect best fit line, the one that fits all the points as close as it possibly can. The calculator, you're going to graph the scatter plot, get the best fit line, and graph that best fit line. The directions we're going to have here and the pictures we're going to have here are for a TI-84, so skip ahead if you have something else and find a tutorial on Google, or ask me and I will find you one that teaches you how to do that with the calculator you have. All right, with the TI-84, if you're entering data, you're going to press Stat. It's right next to the arrows. Then you'll press Enter on number 1, Edit. You should see this picture, possibly with data, possibly empty. You might have stuff in there, you might not. If you have the stuff in L1 or L2, go to the top where it says L1. So you want to go right up to here so that this is highlighted, and press Clear, and then press Enter. If you press Delete, it will delete the whole list, and you won't have an L1 anymore, and that's really frustrating. So instead, press Clear and then press Enter, and what it'll do is it'll clear what's entered in there, right in here. It'll clear that whole list of things. It would have started like that. And then when you press Enter, it clears the whole list. So that's what is helpful there. So if you need to clear it, do that for both lists. And then you're going to type in all of your X values to L1 and all the Y values to L2. If you always do it this way, then your calculator will be much easier to use. You can use L3 and L4. You can swap L1 and L2. It's really not a huge deal. And I will teach you how to do that and change that in the calculator. But it's a lot nicer if you just use your X's in L1 and your Y's in L2, especially if you're at all technologically challenged. When you're done, your calculator screen should look like that. You should have your negative 20, negative 17, negative 15, etc., all your X's in your list 1 and all your Y's in your list 2. So we'll use that previous data we just graphed. Once you've done that, you're ready to graph. All right, so to graph your scatter plot, you're going to press second, then your Y equals. Both of those are up in the top left-hand corner on the calculator. Then you'll get this screen. And they may be off, they may be on, whatever. You want to make sure that plot 2 and plot 3 are off so it doesn't get mad at you, and press Enter on plot 1. You'll want to go down and select on, leave the type as the scatter plot option, the one that's not connected, and then make sure your X list and your Y list are correct. So we're going to make sure that on is highlighted. Make sure the first plot type, that unconnected dot plot, is scatter plot, is selected. And then we're going to make sure that the X list says L1, the Y list says L2. If for some reason it doesn't, on your calculator in blue or maybe another color, right above the numbers 1 and 2, you'll see L1 and L2. To get those list names, you just go to where you want to put it and press second 1, and it brings that up. And so that makes it a lot nicer to put those in if for some reason they got mixed up. Now your screen should show something like this. It doesn't matter which option you pick for the mark at the bottom. This is going to be a little box. This is going to be a plus sign, and this is going to be a dot. For the dot, it's a lot harder to see unless you have a lot of points. The plus sign or the box are what I recommend for now. Once you have this done, as long as plot 1 is on, you can now press zoom, the middle button at the top, and then scroll down to zoom stat. Number 9, zoom stat, is going to zoom right to whatever scatter plot you told the calculator to graph. You can scroll down and press enter, or you can just press number 9. And then you should see our graph. It looks a lot like what we drew. Now that we know what it looks like, we want to find the best fit line. We're going to press stat, and then we're going to go over one to the calculate menu. And under that, you'll see number 4, lin reg, ax plus b. There is another lin reg. We'll use that in stats, but for now we'll use the number 4, lin reg. And that just stands for linear regression, because we are fitting a linear function here, and so that's what that means. Now, if your calculator's fancy, when you hit that, it's going to come up with a menu asking you for X list and Y list and store regression equation and calculate. As long as it has the right list in there, you can leave the regression equation blank and just hit calculate. That'll give you the regression equation seen on the next slide. If your calculator is not fancy, it won't ask you for any of that, and you can just hit enter. As long as you have X in L1 and Y in L2, you can just press enter and you'll get this regression equation. I get 3.861X plus 180.292Y, or B, for B. Underneath that, you might see values for R and R squared. You can ignore that until you take stats. We'll talk about that extensively in statistics, but in Precalc, it really doesn't help us much. So we can ignore those. But the line itself would be here. This means that Y equals 3.861X plus 180.292 for our line. That's our best fit line there. So we are just going to take this value and sub it in here, and this value and sub it in here. Okay, so that's what's going on. Now we have our best fit line. So that is the function I just wrote out. And that means that now we can do things with that line. Like we could predict the y value for an x of -12. We would sub in -12 to the function and solve and get about 133.96. That's what we would expect. We can also estimate the x value for a certain y. We could say, oh, okay, what would I have to do for x to get a y of 110? Well, x looks like would have to be around -18. So everything we can do with a normal function, we can still do with our best fit line. We just have to find it first. So we can do this with any kind of data, even if it has real-world significance. Precalc has significance? No. But really, we can find data everywhere in real life, and a lot of times we can find good linear data. So when that happens, a lot of times we're going to be asking you to interpret pieces of the line. So remember, the slope is the change in y over the change in x. A lot of times in stats, I teach that as it's the change in y, the increase or the decrease in y, depending on if it's positive or negative, for every 1 unit increase in x, whatever that 1 unit is in that context. So let's do one. We have a professor, Grant Alexander, who wanted to find a linear model that relates the number of hours a student plays video games each week, we'll call it H, to the cumulative grade point average G of the student. I know this feels overdone, but it was an example from the book, so I'm stealing it. He obtained a random sample of 10 full-time students at his college and asked each student to disclose the number of hours spent playing video games and their cumulative GPA. This is the data he got. First off, we're asked to explain why the number of hours spent playing video games is the independent variable and the cumulative GPA is the dependent variable. Well, independent means that it changes on its own, and dependent means that it usually changes based on some other factors, right? So in this case, does a change in your GPA cause a change in your number of hours playing video games? Or is it the other way around? It's a little bit symbiotic, right? If you notice your GPA is dropping, you might decrease the number of video games to try to increase your grade point average to study more. But this professor believed that hours playing video games would cause changes in your grade point average or be related to them, and so that's why we did this way. Now we're asked to use a graphing utility to draw the scatter diagram. So grab your calculator, type this in, pause it here so you can see the data, and get that all typed in and graph it. Use those notes that we just took based on how to do this, and do this yourself. This is the graph that I get. Definitely a negative trend. Got some interesting stuff going on here. And I got this from Excel, obviously. But this is the graph shape that you should have. All right. Now we're going to use your graphing utility to find the line of best fit that models a relation between the number of hours of video game playing each week and grade point average. And we're going to express the model using function notation. Function notation. Okay, this really means no big changes for you. Instead of using y equals for your best fit line, we're just going to use g of h equals for your best fit line. So the function I get is g of h equals negative 0.091h plus 3.276. Hopefully, you get something close to that. Why don't you try it out? Was I close? If you completely disagree with me, you should let me know so that I can fix the video or help you figure out what went wrong. All right, now we're asked to interpret the slope. The slope is negative 0.091. That means that the y decreases about 0.091 for, I can't spell today, for every one x. But what are x and y in this case? X is the number of hours playing video games, and Y is the GPA. So we would say the GPA decreases by about 0.091. So you're losing 0.09 on your GPA for every 1 hour playing video games. I wonder if that's per day or per week. Interesting. This is the interpretation, or something close to it, that I would be looking for. We put in context, and we have x and y, and we have that increase or decrease. We have that direction. Now we want to predict the GPA of a student who plays video games for 8 hours each week. So we're going to sub in we'll sub in 8 for x and do the math out. Let's see. .548 is what I get for their GPA, so about 2.55, which makes sense based on these two values. It's close. My trend should be close. How many hours of video game playing do you think a student plays whose GPA is 2.4 based on this data? Well, looking at this, a 2.4 is probably going to be somewhere around 8 or 9 hours. That's my guess. But let's do this with math. 2.4 equals negative 0.091 x plus 3.276. Oops. That's our function. Had to check. And so now we want to solve for x. Let's see. 2.4 minus 3.276 divided by negative 0.091. X equals 9.6 626. So 9 hours, 9.5, almost 10 hours is what this model would predict. Okay. Remember to use your calculator very wisely. It's only as helpful as you tell it to be. So we have to make sure that operator error isn't the reason for our problem. So make sure that you're carefully typing everything in. And always be accurate to 3 decimal places. That's a rule just in general. I like to use, I prefer 3 decimal places. So we're not going to worry about sig figs here, significant figures. We're just going to say, okay, everything to the 3rd decimal place. And that will serve you through AP Calculus as well. And then you need to scale equally. Make sure that if you're drawing a scatter plot, that each hash mark has the same amount apart. So each space equals the same amount on that number line. That's a very easy thing to mess up because you're just going along, okay, that's the next one, and then not paying attention to, okay, this hash mark went from 5 to 7, and then this one went from 7 to 11, and they should be equal, but they're not. Okay, so that's the biggest thing. And now maybe we can move on to quadratics.